Hydrolysis of salts and their pH. After doing the different types of acids and bases and understanding their dissociation constants, and then understanding how they are different, the different acids and different bases are different in their with respect to the relative strength, the concept of weak acids, weak bases. Let us now move to these salts, because salts are the major sources of forming the ions in the solution in the water, and the ionic equilibriums are mainly involving the salts. To first understand the hydrolysis of salt and what exactly it means, we first know how these salts are formed. We have been knowing this from the junior level, that the salts are formed by the neutralization of an acid and a base. So salts are formed by the combination of the acid and bases, and on the basis of the acid and the bases which are used to form the salts basically are of 4 types. So before understanding the hydrolysis of salt, what exactly it is, let us first do the salts are of 4 types depending upon the acid and the base used to form it. The first type is salt formed by the combination of strong acid and strong base. When both of these acids and bases which are combining are strong, the salt formed are called salts of a strong acid and a strong base. The best example of this type of a salt is NaCl. How will you make out this, that the given salt is of a strong acid or a strong base or a weak acid or a weak base or any one of these? First, you must see the cation of the salt. Always remember, the cation comes from the base and the anion comes from the acid. So you have to make out, okay, Na, we have got Na from where? From the NaOH. Cl, from where we have got the Cl? From HCl. So it is the combination of NaOH and HCl which makes NaCl type salt. So this is how we'll make out what type of salt it is. So we know it is the NaOH and HCl which when reacted or neutralized together they form NaCl. Now the other examples of this type of salt, it can be KCl, Ki. You can take the example of barium chloride, etc. How can you make out KCl? From KOH, Cl, from HCl, both of these are the strong acid, strong bases. It's a salt of strong acid, strong base. Ki, KOH, Hi, strong acid. K from KOH, strong base, strong acid. Barium hydroxide is giving you barium, strong base. HCl giving you the Cl. So it's again combination of strong base, strong acid. Now, in these type of salts, when such type of salts are added to water, like this salt is added to water, in the solid state is added to water. Remember, we don't have any weak salt in the syllabus. All salts will be strong electrolytes. They will be showing 100% dissociation. So when this salt is added to water, it is going to form Na plus aqueous ions and Cl minus ion aqueous. Now these sodium and chloride respective ions which are existing in the aqueous medium are very strong corresponding conjugate acids and bases. NaOH is a conjugate acid of NaOH base and Cl minus is a conjugate base of a HCl. So this is a conjugate acid, it's a conjugate base, and these are very strong conjugates, are very stable conjugate bases and acids, which is not going to react with water again. So in those cases, the Na ion will not going to interact with the water in any case. So nothing will happen to this one. The same chloride ion will not going to interact with the water in any case. So nothing will happen to this. So in these cases, they will remain in the water as such. So remember, these type of salt, they doesn't affects the pH of the solution to which they are added. They doesn't changes the pH, and they doesn't get hydrolyzed. They doesn't interact with water. Hydrolysis of water means how these ions, the respective conjugate acids or conjugate bases which are getting we are getting from the salt, how they are interacting with the water. If they react with water, it's called hydrolysis. So the salts of strong acid, strong base, whatever the cation and the anion they give, they doesn't interact with the water, and they never changes the pH of the solution to which they are added. That is how, if I say that 0.01 molar NaCl is added to a solution of pH equals to 4, what is the new pH? Remember, no change to the pH. It will be 4 only, because this NaCl added is not going to change the pH. So this is what is the first type of salt, which is actually formed by the combination of a strong acid and a strong base. Let us take now the second type of salt, which is a salt from weak acid and strong base. So one of them is weak, other is strong. The best example, weak acid and strong bases, is your sodium acetate. The acetate ion from this salt is from the acetic acid, which is a weak acid, and this Na is from the strong base NaOH, so it's a strong base. So this salt, sodium acetate, actually is a salt of a weak acid and a strong base. Now when such type of an acid, salt is added to water, it gives the corresponding acetate ions and the sodium ions. Now remember, this acetate ion is a conjugate base of weak acid, which is acetic acid. Sodium ion is a conjugate acid of a strong base NaOH. Now this Na ions will not interact with water because they are very stable. But this acetate ion, this aqueous acetate ion, the moment it is formed, it will react with the water, will form acetic acid, and will release, since it has taken out H ions from this water, and will release OH minus ions in the water. Now these OH minus ions will make medium basic. So these OH minus ions will make medium basic. So it means what? The moment you put these type of salts, which are actually are formed by the combination of a weak acid and strong base, makes the medium basic. Therefore, in these cases, the pH will become more than 7. The moment you put them, the pH will increase, because this acetate ion, which is a weak, actually is obtained, which is a conjugate base of a weak acid, immediately gets hydrolyzed. This process is called hydrolysis, and it gives acetic acid back, which is not going to dissociate back because it's a weak acid, and it releases OH minus ions. This OH minus ions in the solution makes medium basic. Always remember, when such type of salts are added to water, the pH becomes more than 7 or it increases. So this is what is your second type of salt is. Let us take the third type of a salt. Salt of weak base and strong acid. In the earlier example, we have seen the base was strong and the acid was weak. In this case, the base is weak and the acid is strong. Best example of this one is your ammonium chloride, because ammonium is from the ammonium hydroxide, which is a weak base, and your Cl is from your HCl, which is a strong acid. Now, when this type of a salt is added to water, it gives ammonium ion aqueous and Cl minus ion aqueous. Now remember, this ammonium ion is your conjugate acid of a weak base, which is ammonium hydroxide, whereas your chloride is your conjugate base of a strong acid HCl. Now this chloride ion aqueous will not interact with water in any case because it is very stable. But this ammonium ion, which is actually your conjugate acid of a weak base ammonium hydroxide, is not very stable. The moment it gets formed in the water, it immediately reacts with the water to form ammonium hydroxide back and aqueous. And since OH ions has been taken out from the water by this ion, what is left is your H plus ions aqueous. Now these H plus ions will make the medium acidic. So when these type of salts are added to water, they will make the medium acidic because one of the ions which will be your ion obtained from the weak base, its conjugate acid immediately gets hydrolyzed, releases H plus ions, which makes the medium acidic. So whenever these salts are added to water, the pH will become less than 7. It will decrease. Remember, it will decrease. And the most easy thing to remember is, if in the combination, whatever is your strong, like in this case the acid was strong, the medium became acidic. In the earlier example, the base was strong, the medium becomes basic. So in this case, these type of salts, due to the hydrolysis of the conjugate acid obtained from the weak base, the H ions are generated, which makes the medium acidic. pH becomes less than 7. Now let us do the fourth type of salt, which is the salt of salt obtained from the weak acid and weak base combination. So salt of weak acid and weak base. Now in this case, remember, both acid and your base are weak. The best example is ammonium acetate. In this, acetate ion is from the weak acid, acetic acid, and ammonium ion is from weak base, ammonium hydroxide. But remember, the salt is a strong electrolyte. It will dissociate completely. So when this salt is added to water, it gives us acetate ions and ammonium ions. Now remember, this acetate ion is a conjugate base of a weak acid, acetic acid, and ammonium ion is a conjugate acid of a weak base, ammonium hydroxide. Now both of these, since are obtained from the weak acid and weak base, they are not stable. They immediately gets hydrolyzed, they will react back, they will get hydrolyzed with water, forming their respective acids and bases. How? Let us see this. this acetic acid will react with the water or will get hydrolyzed and will form the acetic acid. Since it has taken out H from this, it will release OH minus ions. Similarly, this ammonium ion will react with water, will get hydrolyzed, forming ammonium hydroxide and the H plus ions. So, both of these, this is a conjugate base of a weak acid, this is a conjugate acid of a weak base, immediately gets hydrolyzed, forming their respective acids and bases, releasing H plus ions and OH minus ions. In the first stage, we find that, okay, how? Since both H ions and OH ions are released in the solution due to their hydrolysis of these weak conjugates, acid and conjugate bases, the solution will remain neutral. But it's not like this, because how much this acetate ion gets hydrolyzed, how much this ammonium ion gets hydrolyzed, again depends on their dissociation constants Ka and Kb. Not exactly, that's actually this Ka is in this way, backward direction. So it is the opposite of this one. So we will be taking what their values in the form of their pKa and pKb. So it will be depending upon their pKa and pKb. So remember, what we can make out is that both of these will be getting hydrolyzed, releasing H ions and OH ions, which of course will be neutralizing each other, but the net medium out of these, the hydrolysis of these two, will depend on the strength of the Ka or Kb, a value of Ka or Kb. If the acid's dissociation is stronger, higher, more of the hydrolysis takes place, medium will become acidic, or because lesser is here than pKa, less the OH ions will be generated, more of the H ions will be there, the medium will become acidic. Similarly, if the base is stronger, its pKb will be less, lesser will be its hydrolysis, less of the H ions will be generated, more of the OH ions will be there, the medium will become basic. So always remember, therefore, in such type of salts, it's not the concentration which makes difference. It is the actual difference of the pKa and pKb which is going to make the difference. And that is why, not necessarily going into the calculation part, we have a formula for such type of salts, which is the pH of such type of salts is 7 plus half of pKa minus pKb, which is going to decide what will be the pH of the solution when these salts are added to water. Because it is the net difference of these two which is going to decide how much of these two is left out, and that is what is going to decide what is the pH is, not the exact how much of OH ions or H ions are generated from the concentration. So remember, the pH of these types of salts is independent of concentration, and it depends on the relative strengths of the Ka and Kb or pKa or pKb values. Now let us do a numerical to understand how the pH of such a salt, which is actually a combination of a weak acid and weak base, is determined, and as the formula which has been given, that it is equal to 7 plus half of pK plus minus pKb, because it's not depending on the concentration, it depends on the relative strength of the dissociation constants of the acid and the base. Let us do a numerical on this. I'm not robbing the formula, it is still written here in order to make you clearly understand this. The question is, find the pH of 0.01 molar ammonium acetate solution, the pKa and pKb values of acetic acid and base are 4.7 and 4.6 respectively. So what we find is pKa is 4.7, pKb is 4.6. Concentration will not make any difference because this is what is your formula is. So your pH will be 7 plus half of your pK is your 4.7 minus 4.6, which is your pKb is. This is going to give you 7 plus half of 0.1. This will be 7 plus 0.05. So this will be 7.05. So this is what is your pH will be when this type of salt with so much of concentration, which is not going to make any difference, is added to water, since it depends on the pK and pKb values.